Welcome to another explainer. So, have you ever stayed up way too late just thinking about time travel? I know I have. It's easily science fiction's most exciting idea, but honestly, it is a massive headache for real-world scientists. Well, today, we're exploring a seriously groundbreaking hypothesis by researcher, inventor, and author Kevin L. Brown. He's put forward a framework that finally solves this headache, proving exactly why the universe's timeline is completely safe from our favorite sci-fi mistakes. Let's get into it. Here is the absolute classic time travel dilemma, the grandfather paradox. Imagine you build a time machine, you travel back in time, and you accidentally, or hey, maybe on purpose, do something that stops your own grandparents from meeting. That means your parents are never born, which means, well, you are never born. But wait, if you were never born, how do you ever build a time machine to go back in the first place? It's a giant loop that literally breaks our brains. It's a total contradiction. But does the universe really work this way? Okay, let's dive into our scientific roadmap for today. First, we'll look at the paradox problem. Second, triune harmonic dynamics. Third, the causal ledger. Fourth, measuring pressure. Fifth, testing and falsification. And finally, number 6, real-world implications. All right, section 1, the grandfather paradox problem. To really understand the solution here, we first have to realize why our traditional pop culture view of time travel is completely broken. Our existing understanding of time is usually like a straight line drawn on the piece of paper. We call this a linear time model. The problem is, when you force a paradox into a linear model, the whole system just crashes. It creates these impossible contradictions, kind of like a computer completely freezing up when you give it a bad command. But the research by author Kevin L. Brown offers a completely different view, which you're calling the THD reality. Instead of a fragile straight line, time is actually a structural system. It has actual physical boundaries, kind of like walls, that simply cannot be broken. Moving right along to section 2, triune harmonic dynamics, or THD. So what exactly is this new structural system? Well, triune harmonic dynamics, or THD for short, is a mathematical framework developed by Kevin L. Brown. The core idea here is mind-blowing, but surprisingly simple to grasp. It suggests that all change in the universe, whether it's a massive star forming or just a thought popping into your head, follows a universal, measurable rhythm. It treats reality way less like a random collection of events and more like a beautifully organized song. It offers us a real, physics-based solution that we can actually understand. And this brilliantly illustrates how it works. Kevin L. Brown breaks this universal rhythm down into a 3-6-9 mathematical phase. Think of it in 3 easy steps. Step 1 is form, where a structure is born or created. Step 2 is transformation. This is where that structure goes through a testing phase or experiences tension. Finally, step 3 is integration, where the tension resolves and things settle into a brand new, higher order. Basically, everything in the universe goes through this exact cycle to refine itself. And yes, that includes the timeline itself. Which brings us to section 3, the causal ledger hypothesis. Now, what's really interesting about this slide is how we apply that rhythm. How does this 3-step rhythm actually stop a time traveler from ruining the universe? Let's look at causal paradox pressure. Imagine a water pipe. Water naturally flows in one direction, right? If you try to force the water backward with a massive pump, pressure builds up. Eventually, something has to give. The pipe bends, it springs a leak, or the flow just stops completely. The universe works the exact same way. When a time travel event threatens its own existence, this invisible structural pressure builds up. The universe essentially gets stressed out, and it's physically forced to resolve that stress before a contradiction can even happen. So, how does the universe release that pressure so the quote-unquote pipe doesn't burst? According to Kevin L. Brown's research, there are 4 specific resolution mechanisms. First, we have self-consistency. This means whatever the time traveler does simply ends up causing the history they already know. Crazy, right? Second is timeline branching, where a brand new parallel universe splits off, leaving the original one totally alone. Third is causal damping. This is where the universe literally runs interference. A laser rifle mysteriously jams, or maybe the traveler just trips on a rock and misses their chance. And fourth, non-execution. The event is just physically impossible to start, kind of like walking into a brick wall. The paradox simply never happens. Okay, on to section 4, measuring causal pressure. Now, this all sounds absolutely great in theory, but as we know, science requires actual proof. So how do we shift from an interesting thought experiment into observable data? To validate this hypothesis, researchers use specific validation test mechanisms to actually track that invisible pressure. They look at anomaly frequency, which is basically how often weird glitches pop up. They measure volatility, or how sensitive a timeline is to tiny changes, along with a clustering of contradictions, model divergence, and instability metrics. By tracking these numbers in quantum physics and computer simulations, we can literally measure the stress on reality.
Next up, Section 5, Testing and Falsification.
So the crucial point is that a theory is only as good as our ability to test it. As Kevin L. Brown strictly states, here is the falsification parameter. If a time traveler can successfully complete an action that actually erases their own beginning, and the universe somehow doesn't stop it, correct it, or branch off, then the THD hypothesis is proven wrong. Real science always demands a way to be disproven. By setting this strict boundary, the THD framework steps up to the plate and essentially says, test this. Try to force the universe into an impossible loop.
And finally, Section 6, Real-world implications.
If the universe truly defends itself against contradictions, what does that actually mean for us today? Let's trace how our understanding of reality has shifted over the decades. Back in the 20th century, we viewed paradoxes as total roadblocks, just impossible linear contradictions that completely broke our math. Today, thanks to work like the THD framework, we are seeing time as a measurable structure under real causal pressure. It's a system with actual rules. And looking forward to the future, this implies a massive shift in how we view the world. We're moving toward embracing a fully self-correcting universe, one that naturally fixes its own errors to maintain harmony. This explainer leaves us with an incredibly profound idea to chew on. Think about it. If the universe structurally prevents its own destruction at the fundamental, timeline level, keeping everything perfectly balanced, how else is reality self-correcting? From our biology to the environment, all the way up to human society, what other systems are secretly following this beautifully organized rhythm? It's just an amazing reminder of how connected and how incredibly resilient our universe really is. Thank you so much for joining me for this explainer, and as always, keep asking the big questions.